Hi there everyone. Welcome to the video lecture series on complex integration. I'm Mayur Gohil. Let us take up a new type of a question over here where we are asked to integrate or evaluate this integral over the curve C where the function is 2z bar minus z, okay, and the variable of integration is dz, and the curve is now given in a different manner. Curve is x equals to minus t, y equals to t square plus 2, and t is going from 0 to 2. It is in the interval 0 to 2. Now such a type is called parametrization type. Okay, so the curve is parametrically defined and given to us. We need not worry about how the curve looks like or what is the curve. We can, without even drawing the curve, we can solve this integral. Let us see how to go about it. So in such a case, our first step will be understanding the curve. Okay, so nature of the curve and the limits and everything like that. So let us see how to go about it. Now here, if you observe, almost everything is given to us. Okay, so we just have to understand how to begin with. So first, in this step, when x is equals to minus t and y equals to t square plus 2 is given, and here is 0 to t, the value or the range of t is given, like, not the range of t, where the t will be taking the values, right? T is belonging to the interval 0 to 2, so it can be also written in this way. This is just an equivalent form, so it could be written t belongs to 0 comma 2. This also could be the way given to us. So let us see how to approach this. So what I'll start in this case, our step 1, I'll approach directly to z. Let us see what happens. So I'll just find dz over here. Find dz. Let us see what goes. So we know that let z equals to x plus iy, therefore dz is equals to dx plus I dy, right? That is known to us. Now we have something further about it. Let us see. Also, x is equals to minus of t and y is equals to t square plus 2, right? Therefore dx by dt is equal dx by dt, we'll write here dt, that is same as minus of 1, and dy by dt is equals to 2t. Therefore dx is equals to minus of dt, and we are having dy as 2t dt. Okay. Therefore now you see that if I call this as our standard formula as the first one, dz equals to dx plus I dy, and these are two important results that we understand from the parametric equation of the curve, that dx is minus dt and dy is 2t dt. Then from 1, 2 and 3, okay, so from 1, 2 and 3 we get is dz. Now dx is now going to become minus dt equals dz is now minus dt plus I times dy has become 2t dt, so 2t dt. Now just take common, therefore dz equals to minus of 1 plus 2I t dt. Okay, that's what we have, and this will be our important step here. That is, we have got the value of dz now in terms of the variable t. Okay, so this is the first important thing. Okay, so let us go for step number 2. So step number 2 is now understanding the function or simplifying the function. Find f of z. So f of z is given to us. I'll just put a line here. F of z is given to us as 2z bar minus of z. So this is nothing but z is x plus iy. So x plus iy bar minus x plus iy. Now x plus iy bar means 2x minus iy minus x plus iy. But now we have to convert this function into the variable for t, right? X is everything and we are going to go for t. So x is in terms of t, y is in terms of t. So let's get into terms of t. 2 times x is nothing but minus t minus I times y is nothing but t square plus 2 minus x plus iy. X plus iy again minus of t and y is nothing but plus I times, here we will have t square plus 2. Now let us simplify the whole thing. So it is minus of 2t minus of 2I t square, right? And then it will be minus of 4I. Okay, and then here it is minus of minus will make it plus, so it is t. Here we will have minus of I t square, and here will be we will get minus of 2I. Okay, let us simplify a bit more. It becomes, so let us collect the terms which are having the real part and the imaginary part, or the, yeah, in that way we will have minus of 2t over here plus, let's just highlight the terms a bit. I'll highlight it with the orange. So this is a term minus 2t. Then there is this t with us. So let us do that. And now we have yeah. So t minus of 2t plus t, and let us collect the terms with the imaginary part. So it is plus of minus of 2. I'll just take the I outside and keep the other terms inside, minus of 2t square. Okay, and here it is minus of, oh, we could have simplified it a bit. Let's simplify it now. And here it will be minus of t square. Here we have minus of 4, and this is going to be minus of 6. It doesn't matter, let's write it here. So it's going to be, here we will have minus of t plus I times minus of 3t square minus of 6. That's what we have as the simplified version of the function. Okay, now let us go further on this part. This is the function. Let's label it as phi for our understanding part, and now we go for the simplification of the integral or solving of the integral. So step number 3 comes here. Solve for the integral. Solve the integral. Now the integral over here we have is I integral over c f z dz. So when we have this integral, it is fz is nothing but minus of t plus I times minus of 3t square minus of 6. Okay, and we see that dz has got converted from this fourth equation with this, right? Minus of 1 plus 2I t dt. And the limits for t are to be now written. That limits are given in the question itself over here. That is, it is going from 0 to 2. So t is going from 0 up to 2. So that is the integral complete over here. Now let us simplify the integral in the function a bit, and let's solve it. So I'll put a line here. So now let us calculate further. So here we will have I equal to integral 0 to 2. Now this minus 1 gets multiplied with this minus t, it becomes t. Then this minus 1 gets multiplied with this entire term, so it becomes plus of I times 3t square plus 6. Okay, yeah. Now this 2it is there, that gets multiplied with this minus t, so it gives me minus 2it square. Now this 2it gets multiplied with the second term, so I'll just write the full thing for the sake of convenience of understanding. 2it getting multiplied with I times minus of 3t square minus of 6. Okay, and this full thing is going to come with dt. All right. Now let us simplify this carefully. So I going from the integral going from 0 to 2. Okay, 2. I'll just write it 2 properly. 0 to 2, and then you have here t, and then there is this t plus I 3t square plus 6. And then if I take I common from this second bracket also, I'll have here minus 2t square. From here what we will have is minus 2, or rather I would say it will be 2I square t, and then there is minus 3t square minus 6, and that I square is basically minus, right? So let me just complete that, and then there is dt. Now we know this properly, that I square is minus 1. So we will now have the value for I is equal to integral 0 to 2 over here, and then we have t, and this is coming to I times t square plus 6. Alright, and then there is the next term. Now I square is minus 1, so what you do, take that minus 1 inside. That minus and minus makes it plus, so we will have over here plus of 2t times 3t square minus 6 will become plus 6, and then there will be dt. Okay, that will be dt there. Alright, now you collect the terms carefully and we will integrate it now. So the integration I'll be doing the regular way. You can collect the do it directly from the calculator. It's if your institution allows, uh, or if it's allowed in your exam, then you can do it directly. I'll be doing the traditional way. Now this is t and this is 2t and everything is there over there. So I'll multiply it. T plus, here I'll get 6t cube plus 12t plus I times t square plus 6. Okay, and this whole thing comes under dt. Okay, now with dt you start integrating. So the integral, now t and 12t gives me 13t, so it will be 13t square by 2. Then the next one is 6t raised to 4 by 4. Alright, that's the integral for the real part, 0 to 2. For the imaginary part we will have I outside, and here it will be t by cube over 3 plus 6t 0 to 2. Okay, now what is the output over here? Let us see. Now when you do over here, put the upper limits, you will get 13 into 2, because it is 4, right? And 4 divided by 2 is 2. So I'll write 13 into 2. And here you will get 6, 2 raised to 4. 2 raised to 4 is going to be 16 and divided by 4. So it is obviously going to give you 4 there. Okay, right? And then uh, for lower limit 0, nothing is going to get you answer because it's going to be 0. Plus I times, here you have 8 over 3 plus 12. Okay, on simplification of this is 26 and this is 24, right? So this is 50, and this one will be how much? 36 plus 8 is 44, right? 36 plus 8, yeah, is 44. So you have this 44i by 3. So this is the final answer over here. So I'll just put it in the box, therefore, or I just put a highlighter. Yeah, this is the final answer over here. Now see, I did all the steps of integration over here. You can skip it if in your exam the calculator is allowed. Okay, if you are allowed to use a calculator, then what is required is at this step. So I did a lot of simplification. If you can collect the terms quickly, okay, and do get the real part and the imaginary part, you can skip 2 steps. I think over here are possible that you could skip and get your answer. Okay, so this is the parametrization type. So yeah, a parametrization type it is. I hope you have followed the example, uh, and please go through the steps. Please hit like button and share it with your friends, those who find this topic useful and they have in their exam. So I hope it benefits them to solve the questions related to complex integration. Please subscribe my channel for more such educational content. I would be really happy to help you. If you have any kind of query related to this topic, related to this question, please feel free to comment down in the comment section. I will uh, reply as soon as possible. Till then, thank you for watching. Keep solving good amount of mathematics.